Hello everyone, we're from Bangkit Capstone Group C242-PS283, the people behind EcoWise. So our team member consists of 7 people collaborating from machine learning, cloud computing, and mobile development. There are 3 people from machine learning, consists of Noel, Glori, and Yudhistira. 2 people from cloud computing, consists of Bima and Zefanya, and 2 people from mobile development, consists of Gutti and Duma. So in this presentation, we divide it into 6 parts. There's background, reason, implementation, result, documentation, and deployment plan. First, the background. Why we're choosing EcoWise is because Indonesia having a serious waste problem. Indonesia produces 64 million tons of waste per year, and there's 33% of it was not effectively managed based on our research from KLHK. So the reasons why. First off, because of limited infrastructure, that the large portion of waste end up in the environment harming the ecosystem and causing health risk. And the second is public behavior due to number 3 of lack of awareness to handling the waste in the right way. From the existing results show that from to paper there's the missing element from paper 1, the waste scanning only provide an explanation of the type of waste. Second paper, missing element only has scanning feature to display the name of the trash. So about EcoWise. So EcoWise is an application that is designed to raise awareness and educate public to various type of waste by classifying them into specific categories. We aspire to contribute to environmental education and serve as a bridge between technology and environmental consciousness. Here's our SWOT analysis. Our strength is to provide accurate and efficient solution, user-friendly design, educational content build, adopting principle of waste reduction and sustainability. Our weakness is mobile phone usage only, app development maintenance cost is high, image recognition process lies in the quality and variety of data set, and our opportunities are the upsurge in awareness and demand for eco-friendly solution, the market expansion, growing interest in green tech and innovation, competition, and our threat is competition from another eco app, lack of motivation and awareness, technical issue to make the app work in different environment. Our market opportunities is EcoWise position as an educational and practical tool aligned with public and corporate sustainability goal, focusing on increasing global and regional emphasis on sustainable practice and environmental conservation due to waste management issue. Our market trend is going to be potentially expand on sector of education, government, corporation, and urbanization, increasing public awareness of sustainability and change of waste management.
Now we entering implementation part. As for machine learning part, we use Google Colab as platform to process data and build the model. For the library, we utilize TensorFlow to streamline both processing and modeling. Finally, we implemented CNN or convolutional neural network combined with transfer learning to enhance classification accuracy efficiently.
In the cloud computing services, there are 3 tools that we are using. The first one is Compute Engine. Compute Engine is at the heart of our system, utilizing a virtual machine to handle all back-end processes. This includes managing back-end handlers and loading machine learning model efficiently. The second one is Cloud School. Cloud School acts as the backbone of our database management. It stores critical user data. Lastly, cloud storage. Cloud storage is used to store our machine learning model. By placing this model in a secure and easily accessible storage solution, we ensure quick and reliable model retrieval.
These are the tools and methods used by the mobile development team for application implementation, namely Studio as an IDE, Figma for temporary interface design, and MVVM architecture to organize code to make it easy to read and maintain.
So the next is the slideshow a machine learning dataset set up with 19,852 images, resized to 224 by 224 pixels. 60% is used for training and 40% is split for validation and testing. The data is divided into 596 training feeds, 198 validation feeds, and 199 test feeds. The slideshow a machine learning model using efficient P2P2 with data augmentation and pre-trained image net weights. The slide shows the training result of a machine learning model with accuracy and loss graph over epoch. The final test accuracy is 90.3 with a loss of 0.5431, indicating a strong performance and good generalization to unseen data.
This cloud architecture highlights how different components interact seamlessly to deliver an efficient and scalable solution. The mobile app sends a request to the backend host on the compute engine. The compute engine processes the request, fetching user-related data from Cloud SQL if needed, requesting the machine learning model from cloud storage for the predictions. The compute engine responds to the mobile app with the process result or the required data. This is the compute engine and Cloud SQL. And lastly, this is the cloud storage. This database design consists of two main models, user and detail. Along with an enum call status, each component plays a specific role in managing user information and processing WOS management details. The user's tier status is updated based on their accumulated points, promoting a gamification approach to user engagement. Next, the user model stores essential user data, including account details and progression status. Below are its attributes, and for the detail model stores information related to WOS management. It provides description and tips that appear after a user scans a specific type of WOS. Below are its attributes, and this model ensures users receive proper guidance and education on WOS processing based on their scans.
Here is a demo for the mobile development implementation. When first opening the application, user can scan waste and get the scan result in form of type of waste and prediction accuracy presentation. And user can also read articles. User can also register an account and login to earn points every time they scan waste. After successfully login, user can see profile information in the form of name, profile picture, and number of points they earn. User can scan waste, get the result, and read the article, and see user points have increased by 50 every time they scan the waste. The concept of gamification in this application can be seen in the rank menu. In this menu, user can see which user have achieved the highest points. And there is information about the badge that user can achieve based on the point they have collected.
Now that we have covered the implementation and result, let's move on to the documentation. If you're eager to try out the project yourself, here's how you can set it up and run it. For the machine learning, first you need to go to our machine learning GitHub repository. The link is attached. And then second, download our latest notebook version. After that, open the notebook you have downloaded in your Google Colab, and then run the model in your Google Colab and finish.
So step by step to run cloud computing in your local server. The first one is clone our cloud computing GitHub repository by entering this command in your terminal. Git clone our repository URL. After cloning, install dependencies in the folder that has been cloned by entering npm install command. After that, set up PostgreSQL database on Google Cloud Compute Engine. Lastly, run the local server by entering npm start command.
For the documentation of mobile development, you can go to the GitHub link on the slide to get the project code that build and run in Android Studio using emulator or physical device.
In section 6, we got deployment plan. The EcoWise application deployment plan starts from December 2024 with a trial and beta testing phase to find bugs. January 2025, the application will be launched to Play Store while expanding the trash data set. In February to March, we focus on improving the machine learning model and developing classification features. April to May, we add new features and improve the application interface. Finally, in June 2025, the application will enter the maintenance phase to ensure its reliability. There are three important roles in the deployment of this application. There are developer is responsible for the development of the application and supporting technology. Then the second one is marketer that focuses on marketing strategies and expanding user reach. Lastly, environmental expert that ensures that waste management information in the application is accurate and relevant. Here is the budgeting plan for the EcoWise application development and deployment. We categorize the budget into team salary for 7 members, Google Cloud Platform infrastructure, data collection, and research, including prototyping and external experts, and also budget for future development, market research, marketing and sales, and legal expenses. The total budget that needed to deploy the app is $11,800 or 119 million rupiah. Thank you for joining us today.